Hello everyone and welcome to another video from LLM 0 to 100 series. As I described in the previous video, in this video I want to focus on knowledge graph, and to be more specific, I want to show you how to perform Q&A and RAG on tabular data using knowledge graph. So first I will tell you why knowledge graph should be considered as one of your possible solutions when you are dealing with tabular data. Then I will also show you the series schema, which is, as you know, this is a sub-series for LLM 0 to 100 series that we started about a couple of months ago. Then I will go through knowledge graph fundamentals. I will tell you about nodes, relationships, and knowledge that we need in order to construct a knowledge graph from our datasets. Then I will tell you how to construct a knowledge graph. Then I will show you the ChatBot schema, the chatbot that we want to design in this video. Then I will go through the knowledge graph agent that we want to use from LangChain. And after that, I will go through RAG approach, the approach that we want to use to perform vector search using graph database on our tabular data. And then I will cover two projects. The first one is the one that I've developed for this video specifically, in which we are going to take our tabular data sets, create and construct the knowledge graph, populate our graph database, and start interacting with our graph database. And at the end of the video, I will cover a project from Microsoft in which they have developed a medical chatbot from unstructured data. And I think that is a fantastic project, and it gives you a much greater vision on how you can use knowledge graph and what are the use cases for this specific approach. This slide helps you understand when knowledge graph can be a better choice compared to a RAG project, a RAG pipeline. So first of all, knowledge graph is suitable for both structured and unstructured data. And in this video, we are going to see both scenarios, and I will show you two different projects. For the structured data, we are going to build a chatbot ourselves, and for the unstructured data, I will cover quickly a Microsoft project to show you how it works. Next, domain-specific applications. So knowledge graph is very powerful, especially if the desired knowledge that you want to construct from your dataset is already known. So for instance, if you have multiple tabular data, and if there are specific relationships that you know they exist within your tabular datasets or among them between those multiple datasets, that knowledge is going to help you to construct a much more effective knowledge graph and helps you to leverage the knowledge shared among those databases in order to have a much more powerful chatbot compared to designing a RAG pipeline on top of those tabular datasets. Knowledge graph also brings explainability and traceability to the table. So it allows us to ask questions that can be answered using multiple knowledge points within a single database or even multiple databases, which is not accessible with normal RAG and direct Q&A, and you can exactly trace where that specific answer came from. So what are the use cases for knowledge graph? The first use case that knowledge graph can have a lot of use cases, but just to give you some idea, the first one is, for instance, a chatbot for unstructured medical reports from multiple doctors or hospitals. For instance, you can ask how many of the patients were diagnosed with that specific disease, or these type of questions that, again, you cannot use RAG to get the answer for them. The second scenario is a chatbot for accessing complex relationships between tabular databases. But on the other side, RAG also has some advantages compared to knowledge graph. So RAG can be implemented very easily, but you just have to keep it in mind that you are just relying on some sort of a semantic search between the question and the content inside your vector databases, and that would be it. So for instance, let's make it simple. You want to get the average age within your CSV file. So you have a column called age, and you want to get the average. RAG cannot give you that answer, but leveraging LLM agents and leveraging these type of approaches allow you to interact with your databases and ask exactly these type of questions. So knowledge graph compared to RAG is not as generic as the conventional RAG approaches. It requires more technical knowledge. The slower implementation, so based on experience, I found Knowledge Graph to take much more time to develop and to test. And the final advantage of RAG is, in my opinion, RAG is right now more mature than Knowledge Graph. So deciding whether to use a Knowledge Graph or conventional RAG depends on your data's characteristics, your application's specific needs, and considerations such as scalability, flexibility, and explainability. So again, one thing to mention about the explainability, in case you have a sensitive data, again, just like the one that I mentioned, the medical reports, this is a sensitive data, and the answers that you're getting from that data is very important. Explainability will be super important to those type of pipelines. And you can also consider to use a combination of both if it suits your use case. So I'm sure I'm going to be asked after this video, like, can we combine Knowledge Graph and RAG? Yes, you can combine them both. You can leverage Knowledge Graph, RAG. You can even use SQL agents in order to connect and communicate with your databases. At the end of the day, everything depends on your project specification and what you want to do with your project. One very important note is the LLM model matters. To be more specific, there are two features of LLMs that are very important to me. The first one is the context length, and the second one is the cipher query knowledge of your LLM. So when we are connecting these type of agents, like the SQL agent that we saw in the previous video, or the knowledge graph agent that we are going to use in this video, to our databases, there is a great chance that the amount of data that is going to be processed using that large language model is going to be huge. So the context length and the understanding of your large language model from the data that is processing is super important. And the second one is the knowledge for cipher query, because again, to my personal experience, I used GPT 3.5, I used different type of actually GPT 3.5, I used GPT 4, and as I started to use the most recent models of OpenAI, I realized that the performance of the large language model is getting better and better. This is the series schema that I started in the previous video. So as you know, in the previous video, we covered the blue pipelines, and we used a SQL agent to start interacting with our SQL database. In this video, I want to go through the green pipeline. So here, I want to use Knowledge Graph agent to perform Q&A on tabular databases. And I will also show you the second approach of using RAG with tabular databases. And on the second part, which is going to be the last part of the video, it's going to be much shorter, I will just quickly cover the Medical Chatbot project. So here I want to go through some of the fundamentals that you need to understand what is Knowledge Graph and how to construct the Knowledge Graph. Knowledge Graph is a database that stores information in nodes and relationships. Node properties, we are calling them key and values, and they can also have labels that groups them together, and relationships have direction, type, and properties. So let's go through this simple image here. As you can see here, we have two nodes. One of them is person, the other one is YouTube video. The relationship that these two have, so keep it in mind that relationships contains two nodes. The relationships that these two have together is the person produces the YouTube video, and that person can have a key such as name and a value such as Farzad. And you can also see the direction, the type, and property of that relationship. And this is the way that we represent that relationship between those two nodes in text. So as you can see, the nodes are inside parentheses and the relationships are going to be inside brackets. So let's make this node a little bit more complex. So I have two nodes, person, both of them have a relationship with YouTube video. One of them produces YouTube video and the other one watches the YouTube video. So again, if you check here, you will see that in the text style, I can write the relationship and the nodes like this. So I have a person that produces YouTube video, and this is the direction of the relationship. And the other side, a person watches the YouTube video. So again, each one of these nodes and relationships can have its key and value, or its properties, let's say. So for instance, for this node, I can have the key name, the value Farzad. For this one, let's say the key is name and the value is Mike. So for the properties itself, I can have period, weekly. For instance, the properties can be specific to that relationship or to that node. So they don't need to be similar. For instance, here I can have a property that is year and the value is 2024. And for the YouTube video itself, I can have the topic, let's say AI projects. So how to construct the knowledge graph? The first side is to have the knowledge on how to construct a knowledge graph. So in case you already know how to construct a knowledge graph, that would be the ideal scenario. That is the best case scenario for using this technique. And as you can see, the positive is probably the most highlighted positive aspect is consistent graph structure, which I will explain what do I mean by consistent here. And the other one is that the negative aspect is that it is not easy to implement. So you need the domain expertise to construct the knowledge graph. The second approach is to use large language models to build and construct the knowledge graph for you. So the advantage would be it is easy to use, and the disadvantage of this approach would be the inconsistency in the knowledge graph structure. So now let me explain what do I mean by consistency and inconsistency in graph structure. So as you know, large language models are non-deterministic, which means that when you pass an input to them, the output is going to be generated based on the probability of the next token. So if you pass the same input to a large language model, there is a chance that the output differs after a couple of runs. So that is what I mean by inconsistency. So if you start passing a text to a large language model and ask that large language model to construct the knowledge graph for me, there is a great chance that if you start passing that text multiple times, the knowledge graph that is going to be generated in the output differs from the previous ones. So that is what I mean by inconsistency. And that is probably the biggest downside of using large language models to do it for you from the ground up. So that is just the most important thing to keep in mind. And one of the large language models, the very famous ones that you can go and explore, is called LLM Graph Transformer. There is a lot of information about it on the internet, so feel free to search. And also LangChain uses it. So you can actually use LangChain to use this transformer model, and this is just a great model to use. However, there is another approach that I want to highlight, which is a hybrid method. So the way that I personally like to construct knowledge graphs is not to fully rely on large language models, but to use them in order to, let's say, to come up with a good structure for my dataset and databases. So in case I don't know exactly what knowledge graph I'm looking for, I will start communicating with the large language model until we can come up to a solution that suits my project in order to build the knowledge graph. So by that, as soon as I have that structure, then I can either construct that knowledge graph myself, or again, I can use a large language model and instruct that large language model to construct that a specific graph structure that I just developed with the help of another model. Again, the whole point is to have that consistency. So the pros of using a hybrid method is consistent graph structure, and you definitely would need less expertise in order to build that structure, because now you're consulting, let's say, with a large language model. The cons is still it requires some basic knowledge of coding and graph knowledge implementation. This is the scheme of the project that we want to develop in this video. So the green pipeline is representing the data preparation for graph database. As I mentioned, I'm going to use tabular data, and for that, our pipeline is able to handle CSV files and Excel files. From those data, we are going to construct the knowledge graph, and we are going to populate our graph database using the constructed knowledge graph. The yellow pipeline is for interacting with the graph agent and graph database. So as soon as the user asks a question, that question is going to be passed to a graph agent. That agent is going to create the Cypher query use it to query our database, get the results, and up to this point, everything is automated and we don't need to do anything. But what we get at the end is the final answer from the agent for our question. The blue pipeline is for interacting with the embedding model, LLM, and graph database. So as I mentioned in the previous video, I want to show you a second way of performing RAG with tabular data. In this video, I want to show you how to convert one of the columns into vectors, get the embeddings, store that embedding into a graph database. So as soon as the user asks a question, that question is going to be passed to an embedding model in order to get the embeddings. Then we're going to perform a vector search using the question's embeddings and the vector index in our graph database. Then we are going to retrieve the content. Some results would be retrieved. We are going to pass those results along with the system role, along with the user's question to a large language model to get the final answer. So I mentioned that I'm going to use a knowledge graph agent in this video. In the previous video, I showed you how to use a SQL agent in order to interact with the SQL database. So if you remember, I mentioned the difference between the agents that we are using and a Q&A pipeline versus a RAG pipeline. This is something that I covered in the previous video. And I mentioned that an agent would get the question that we passed to it. So technically, it's going to be the first step of an agent, which is an LLM. That LLM is going to convert the question into a query that our database understands. So in the previous video, our database was a SQL database. So it was converting our question to a SQL query. Then it uses that query on our database to get the results from our database. Those results are going to be passed to a large language model in order to get the final answer. I brought the previous agent here because if you have watched the previous video, it would be much easier for you to understand how the graph agent works, because technically the performance is exactly identical. The only difference is instead of a SQL database, we have a graph database, and instead of SQL queries, our agent needs to convert the question to Cypher query. That is the only difference. So the question is going to be passed to an LLM, Cypher query is going to be generated, it's going to be used on the graph database, then the result is going to be passed to a large language model to get the final answer. Again, I'm going to use LangChain agent for this video as well, just like the previous one. So I found out that these agents are a great head start. Even if you want to design your custom agents, it is good to have these agents on the side in order to compare the performance and see how they would do on your databases. And for the second part of the pipeline, which is interacting with the vector index in our graph database, I want to show you how to convert one of the columns, which we are going to create synthetically, actually in this video, get the embeddings, and then store it in a graph database, and then start to perform RAG on it. Okay, so to construct the knowledge graph for our chatbot, I want to use a dataset, which is a movie dataset. It contains some information about different movies. So it contains the movie ID, the release date, the title of the movie, the actors, the director, and the genre of that movie, along with the IMDb rating. So this is the knowledge graph that we want to construct from our dataset. So our dataset is going to have a person node that is going to have two different types of relationships with our movie node. So as you can see right now, movie is the central node. Somehow movie is that dot that is going to connect all the other dots together. However, there is no limitation on how big your graph knowledge can be. But this is just, again, a demo of how you can construct a knowledge graph, for instance, from right now two different data sets. Because as you can see, I also have some nodes that do not exist in our dataset. So I'm going to create them synthetically. So our person node is going to be connected to the movie either through the directed relationship or through acted in relationship. So these are the two columns that are going to be stored in our person node. and we are going to break down each column, and we are going to actually extract each individual from those columns. So it's not going to be as we have it here, but it's going to be, for instance, Tim Allen is going to be an actor in, let's say, Toy Story movie. Then our movies will have a relationship with genre, and the relationship is our movie is in genre, and then we are going to connect the second node to that relationship. And these small tables on the side of each node represent the properties of that node. So our person node is going to have a property which is a name. That name is going to point to any of these, let's say, these names in director or actor's names. But depending on which name was selected, that name is going to have a different relationship with our movie node. So if, for instance, Forrest Whitaker was selected, that name is going to get connected to our movie node through the directed relationship. For the genre node, we have a property again that is the name, and that is just simply the genre of that movie. Our similar movie has property name, which is the name of the movie. Our location again has one property, which is name. Our movie node has multiple properties. It is going to have the ID property, as you can see it here. It is going to have the release date, the tagline, title, and IMDb rating. So tagline is again a column that I'm going to create synthetically, but you can see title, IMDb rating, and released also in our database. So this is the knowledge graph that we want to construct from this dataset, and I will show you how it's done in a few minutes. This is the second part of the video. So as I mentioned, I'm going to cover a Microsoft project, and in that project, there are two main things that we are going to see. The first one is how to prompt an LLM to construct the knowledge graph for us. So in the first part of the video, which is this one, I want to construct that knowledge graph myself. But on the second part of the video, we want to use a large language model to construct the knowledge graph for us. So what would be the use case for that? In case you have an unstructured text data, for instance, that is just not easy to create knowledge graph from it, you can leverage a large language model to do it for you. The next thing that we can learn from that project is how to create knowledge graph from unstructured text. This is exactly what I was talking about. All right, now I want to show you how to implement the things that we covered in the presentation. But first, let me show you this chatbot, the project that we want to develop, and just to give you an idea of what we are doing when we are going through all the notebooks. So this is the chatbot that we want to design in this project. And I've already asked a couple of questions from the chatbot, and you can see that it gave me the answer for all of them. Our chatbot has three functionalities. The first one is to perform Q&A with Graph Database using improved agent. The second one is to Q&A with Graph Database using simple agent. And finally, performing RAG with Graph Database. So don't worry about these improved and simple. I will talk about them, and I will show you what do I mean when we are going through the notebook. But just keep this chatbot in mind as the big picture. So when we are going through the notebooks and when we are preparing the database, this is what we want to accomplish. So in order to prepare the chatbot, the first step is to prepare the graph database. I'm going to use Neo4j for the graph database. And there are two ways that you can use and create graph databases in Neo4j. The first one is to use it remotely using their web service, or you can use the desktop version. So this is what you will see as soon as you open up Neo4j desktop for the first time. And you will also see this example project. They provided you with an example as well. In order to make the graph database work, there are a couple of steps that you need to go through, and there are some changes in the configurations that we have to apply manually. So in the README file of the project, if you check it, I have provided you with all the steps necessary in order to make the vector database work. But in this video, I want to go through them one by one so you can see actually how that works, because if you are doing it for the first time, it is going to be a little bit confusing, but as soon as you go through it a few times, everything will be much more clear. So in the execution section, I wrote create and start a graph database in Neo4j remotely or using the desktop app. Upgrade your graph to be at least version 5.17 and then install the plugins. So let's go through the first two steps. So I've already opened my desktop. I just click on new, create a new project. Let's also change the name of the project to sample movie project. You know what? Let me just call it sample movie. Okay. So in the next step, click on add and add a local database, or you can also connect your database if you have created it using their web service remotely. You can use this option in case you created the database remotely. But I want to create a local database. So the name of the graph database, let's just call it GraphDB as it is. I will give it a password. I will give it a simple one, 128 for this video. There is a great chance that when you are creating your database for the first time, by default, it's going to be on 5.13, I assume. So make sure that you choose at least 5.17. And the reason behind that is we want to use GenAI plugin on the database to perform RAG and to perform the vector search. And as far as I've explored and realized that 5.17 is the minimum version that allows you to do that. So in case you're using the previous versions, you may not be able to perform the vector search on them. So it's already on 5.17 for me. I just click on create. All right, so my graph database was created. In the next step, which is step 3, I wrote install these two plugins. So let's go to graph database. So as soon as you click on the graph database itself, you will see some details of the graph database, the version, edition, and status. You can also reset the password in case you forgot the password. And here you see the plugins. So I need 2 plugins for my graph database. First, install this one, and then install the data science library. Perfect. I have my plugins ready. In the next step, it says modify the config file of Neo4j, and these are the modifications that we need to apply. I will explain what they are in a moment. So first, let me show you how to find this file. So in order to modify the file that I showed you, you can either click on these 3 dots and go to settings. This is that config file that we want to modify, or open folder and open configuration. So as soon as you click on that, it is going to automatically open the folder in your hard drive that contains the configuration files for your graph database. And here you see we have Neo4j config. This is the file that we want to modify. So let me just open it right here. Perfect. So this is my file, and these are the modifications that I want to apply. The first one is comment out server.directories.import equal to import. So this is exactly here, right on the top. I'll comment it out. And uncomment dbms.security.auth enable equal to true. This is already uncommented for me, so that is great. The next step is make sure this line is set to. So first, let me copy the line. True. And of course, it should be uncommented. So what we are doing is we are giving our graph database the permissions that it requires to interact with our CSV files locally, because the graph database automatically will not allow you to load the CSV file and read the files from it. But with these changes, we are actually allowing it and just giving it the right permissions. And then in the next step, make sure that this line is set to this one. So if you pay attention, there is one main difference here, and that is GenAI. So I just added GenAI to the plugins of my graph database so we can use it for the vector search. So I'll comment this one out and I'll add this line here. Next, make sure this line is set as, so let me search, actually it's right here. So first of all, I need to uncomment this line, or let me just completely copy this line and paste it here. Again, I want to activate the GenAI plugin for my graph database, and these are the two steps that are required for that. And finally, copy the GenAI plugin from products folder into plugins. So up to this point, all the changes that we needed to apply to our config folder is done. So let me just save using Ctrl S, close the config, and go back to my desktop app. I will again go through these three dots, open folder. And here you can either use the DBMS folder or you can use plugins. It doesn't matter. So I will just jump onto my DBMS folder. So this is the folder that contains all the information for my database. As you can see, I have the products folder here. If I go here, I will see Neo4j GenAI plugin automatically generated in my products. So this is not something that you need to download or you need to find by yourself. You can just find it in products here. That is why I mentioned upgrade your graph database to minimum 5.17. So I will just copy it and I'll go through plugins and I will paste that file here. So this is all the steps that you need to take in order to make your graph database functional using the tabular data that we want to work with locally. And also keep it in mind that in case you want to use the graph database with a different source of data, for instance, your data is sitting on blob storage in Azure or somewhere else, there might be some other changes that you would need to apply to make it work. But for our datasets, which are located in the data folder in my project right here, this is going to be just fine, and we can now start interacting with our database. So that's it. The next step is I open my graph database, the desktop version, and I will start the graph database. Perfect. So the graph database is now running. So technically it means that we can connect to graph database and start interacting with it. But right now our graph database is empty. There is no data in our graph database, and we are going to populate it in a moment. So in the next step, I want to go through all the necessary knowledge that we need in order to design our project. But just to go quickly through the project structure, just like the previous projects, we have the configs folder with the config inside it. We have our data folder that contains our data, which is the movie CSV. But actually, I'm going to download that dataset directly. You will see it in a moment. We have the Explore folder that contains all the notebooks that I want to cover. And then we have all the codes for our chatbot and its backend in the source folder. So as soon as you open the Explore folder, you're going to see 4 notebooks in the Explore folder itself: empty graph database, Explore movie data, test connection with graph database, and test GPT with graph database. So these are just 2 notebooks to allow you to verify, first, your connection with the graph database, and second, your connection with OpenAI and your GPT model and your embedding model. So I'm not going to run this one, but in case you face an issue with OpenAI, come to this notebook, make sure that you can establish a connection from your PC or laptop to OpenAI models and start interacting with them. And as you can see here, like by these 3 green check marks, it shows that I can connect to my graph database without any issue. And from here, I can start interacting with it. Okay, so now let's go into movie RAG graph database. If you open this folder, you will see a subfolder Q&A and RAG using OpenAI directly. As you know, I use Microsoft Azure to interact with the graph database, but you can also use OpenAI directly. So I provided you with some notebooks that uses OpenAI model directly. However, you need to establish the connection with OpenAI by yourself. So these are the 5 notebooks that I want to go through in order to design our chatbot. The first notebook is to prepare and save movie data. This is the URL from which you can download the data. And for simplicity, I'm only loading the first 20 rows of that data set. And this is just some more information, the number of rows and columns. You see that there are 7 columns with these column names. And these are the title of the movies that we have in our data set. Next, I want to create some synthetic data. So the thing is, the whole point of using a knowledge graph is not only to be able to create and construct that knowledge graph within your database, but also to create and construct the knowledge graph among multiple datasets and databases. So I don't have a second database, but this cell right here is creating 3 separate column names along with their values synthetically, and I'm just going to consider it as my second database. So imagine that I have 2 datasets. One is movie and the other one is this one right here. And there is a mutual column in them which I can use in order to merge or to just connect all the dots together. Let's say for simplicity, I have the title, like the original movie names, in this dataset as well. So for each one of these movies, I have a tagline, which is an explanation of that movie, a short description. I have a location. For each movie, I'm also creating a similar movie. And also keep it in mind that all this data is synthetic, and like the data itself might not be correct. The descriptions, the country, or the similar movies might not be actually relevant. However, it is going to do the job for us, and it's going to allow us to create that graph database that I showed you in the presentation. So I will create these lists and I will just add them to my data frame. So this is my data frame right now. So imagine again that I just merged 2 different data sets. So I have my data frame ready. I will save my data frame. Perfect. So as soon as you save your data frame, it is going to be saved in data folder movie_CSV. So this CSV file is going to be the file that we just created together in this notebook. In the next notebook, I want to prepare the data from my CSV file, and I want to populate my graph database. So let's go through it step by step. The first cell is just for uploading some of the libraries that we want to use. I'm going to use LangChain community, and from there I'm going to load Neo4j graph. I'm going to use pandas to load my CSV file and see how verify what we are doing. And I'm using piperage root and here just to avoid using the absolute path in my project, so you can easily use the project in different operating systems. In the next step, I just connect to my graph database. Here is the description of the knowledge graph that we want to create from this database, the same knowledge graph that I showed you in the presentation, and here is the image of the knowledge graph. So I will explain the process while I'm going through the code, but feel free to pause the video and go through the description as well. So here I'm just trying to load the data frame and see the column name. So when I was developing it, I was just trying to look at the column names and think of different ways that I can create the knowledge graph from them. So this is why I have it. Plus, I'm going to use the path, the directory of the data frame in Cypher query that we are going to use for populating our graph database. So this is the knowledge graph that we want to create, and this is the code that does it for us. Okay, now let me explain to you how we can construct the knowledge graph from our CSV file. And I will also print the top 3 rows of our CSV file so I can start explaining easier. Keep it in mind, in order to interact with the graph databases and also be able to query those databases, having a basic knowledge of Cypher query is essential. I've also provided you with a separate notebook called Query Movie Database with Cypher. And I provided you with a bunch of different Cypher queries just to give you a chance to familiarize yourself with these type of queries and understand what happens inside them. But in general, In case you are familiar with pandas, and in case you are familiar with SQL queries, it is a very quick catch and you can easily understand what is happening inside those queries. It just takes a few minutes in the beginning, for the first time, but as soon as you spend a few minutes and understand what is happening, then that would be super easy. Okay, let's go through each piece and see what is happening. First of all, in order to create the knowledge graph, I load my CSV file and I loop over each row and I take the value of that row. So this is how I'm loading my CSV file. This movie directory is a variable that I defined in my Cypher query, and I'm passing this value to this variable. And this value is just the directory of my CSV file, and it only accepts a string, so keep that in mind. I take the values of each row and I store them in this variable called row, and I can access the value of each column using, for instance, row.title. In case I'm in the first row, row.title will bring Toy Story for me. This is exactly identical to Pandas query. In each row, I'm going to create the nodes that I had in mind, these 5 nodes, and I'm going to assign their properties values, and also I'm going to create the relationship between each one of those nodes to the other one that they have a connection with. So let's go through them step by step. Using merge, you can start creating a node and assign it a label. For instance, the first node is movie. I'm assigning it label movie. This is another node and I'm assigning it the label person. To movie node, I'm assigning the value of all its properties. So it has an ID, it has released, title, tagline, and IMDb rating. And again, you see how I'm passing the values for each one of those properties. And in case you need to convert any of the values for that row, you can do it inside Cypher. For example, here I'm converting released, which is a string, to date, and I'm also converting IMDb rating to float. After creating the nodes, you can also create the connection between that node and whatever node that it needs to be connected to. For example, person node connects to movie. So let's look at here. Person node connects to movie with 2 different relationships. It is either directed or acted in. And the relationships depend on the column that it was extracted from. So for example, if it was extracted from actors, it is going to be connected to movie using acted in. If it is extracted from director, it is going to be connected to movie using the directed relationship. So for instance, for this node, person, which is coming from the director column, I'm connecting that node to movie using the directed relationship. So the relationship starts from person, and P represents person here. It ends in M, movie, and M represents movie from here. And the relationship between them is directed. There is only one last thing that I want to mention. So this whole query is a big for loop over the rows of my data frame. But some of my columns might have multiple values stored in them. So for example, actors, director, and genre have this characteristic, and they might contain multiple values, as you can see here. However, these values can be easily distinguished and separated using this separator right here. So since I want to create a node for each one of these names or each one of these genre, what I will do is I will also loop over each one of those column values, and I extract each one of these names and I create a separate node for them. So this is what I'm doing here. For example, let's go through this one. For each actor in row.actors, so for each actor in row.actors, and you can understand each one by using this separator, as you can see here, create a node and create the relationship. We have 9 columns, but you just saw that we are going to also break down each column value in case it contains multiple values. So let's first run this cell. Let's print the schema. Perfect. So we can see all the relationships and the nodes and the data types that they contain here. And let's print the number of nodes. You can see that our number of nodes is 155. So up to this point, we created a graph database and it contains all the information that we had in mind. And now we can easily start asking questions from this graph database in case we know cipher query. So right now I can easily start. Let me just quickly ask, find the name of a person that is Tom Hanks and just return it to me. Here we go. So there was indeed a Tom Hanks in the person nodes that I have in my graph database. So you can start easily interact with your graph database, and the database contains all the information that we had in mind. In the next step, my goal is to create embeddings from tagline column. As you can see, tagline is somehow a description of each row. Technically, it's a description of each movie, and each row belongs to a separate movie. So I'm going to create the embeddings of tagline and store those embeddings into my vector index. So let's do it here. So load the libraries. I will load the data frame, load the OpenAI credentials that you want to use with your embedding model. Actually, I'm going to use this one. Okay. And then I will just create an instance from my Azure OpenAI, and I also create a function that can take a text file and give me the embedding. So I will just use that client that I just created in order to generate the embeddings, and I return the embedding of whatever text that I pass to this function. Perfect. So for instance, let's print a few of the taglines in my dataset. These are the taglines. And in order to generate the embeddings, I can just start passing that function in a for loop to each one of those taglines. So I just created the embeddings, and let's see what we did. Number of vectors 20, because we have 20 rows in my dataset, and now I have 20 different vectors. The dimension of each one of those vectors is 1536, which is the embedding dimension of this model. And it is important because when we want to create the vector index in our graph database, we need to pass the dimension to it. And this is the top 5 value of one of the embeddings as an example. I have my data frame. I create a new column called tagline embedding, and I assign all those vectors. So if you look here, you will see that in my tagline embedding, each row now contains a vector with 1536 values in it. In the next step, I create a vector index inside my graph database. This vector index, for now, it's going to be empty. Again, I provided you with all the comments that explains what is happening in each row, but essentially I'm creating a vector index, I'm assigning it the dimension that we just saw, and also I'm assigning it a similarity function, which is a cosine similarity function as a default. In the next step, let's just print some information about that vector index that we created. These are the descriptions of each one of these lines here. So just keep it in mind that ID needs to be a unique value. Population % is the number of values inside your vector index compared to all the nodes in your graph database. So right now, since I have a tagline for each row, my population percentage is 100%. So next, I want to populate my index. Just like the way that we assigned properties in the previous Cypher query, you saw how I'm assigning this property, for example. I'm going to use the exact same Cypher query, but to assign a new value to it. So I'm going to loop over my data frame. This is my data frame. I'm going to loop over my data frame. I'm going to take the rows of my data frame one by one. I'm going to extract the movie ID, and I'm going to extract embedding. I query my graph database. I find the node with the same ID as my movie ID, and to that node, I assign a new property called tagline embedding, and to that property, I assign the vectors in my data frame. So we just created a vector index, we populated that vector index, and now that vector index is queryable and we can perform vector search on it. So let's do one. So again, print the schema. If you print the schema, you will see that a new properties is added to movie, and it's called tagline embedding, and it is a list. Let's extract something randomly. So with this Cypher query, I go through my graph database and I extract any node that contains tagline, and tagline is not null in that node, and then I return it and I print the value. So this is somehow just randomly picking one of those nodes. So these are the two values that it returns. The adventure takes off, and this is the tagline embedding for that specific node. Perfect. So it is safe to say that we just went through the most difficult step of preparing this project, because constructing the graph knowledge and populating the graph database, in my opinion, is the most difficult part of this project. So now in the next step, I can start and ask questions from my graph database using a LangChain graph agent. So just a reminder, as I showed you in the chatbot, my goal in this notebook is to design two different agents. One is just, I'm calling it a simple agent, which I will show you what it is in a moment. And then we are going to work with the agent and improve it a little bit. I will show you why, and I will show you how in this notebook. So at the end, we are going to have two different agents, and I'm going to use both in the chatbot. So first, let's load some of the libraries that we want to use. I'm going to use LangChain community, and I'm also going to load my OpenAI credentials, and I'm going to create an instance for my large language model, and also I'm going to connect to my graph database. There is one note that I want to add right here. Actually, all my notebooks have these two models in them. I explored with two different GPT 3.5. In the presentation, I mentioned that the LLM model and its capabilities in writing Cypher query and also its content length is very important. So with these two GPT models, actually I found out that this one performs better than this version, GPT 3.5 Turbo 1106. So even by switching between the same model, but different versions and different release of that model, I received different performances. This one performed better. That is why I mentioned in that presentation that your model is important. And in case you use GPT-4, that is going to be even more powerful than these two. And to a great extent, actually, GPT-4 is superior compared to these two for two main reasons. Its context length and its ability to write code, or let's say to write Cypher queries. I'm going to use this model, the weakest model, let's say, that I found out based on my experience, just to, again, give you the start. So from here, as soon as you start improving your model, you are just going to make the chatbot perform better. So I have my connection to my graph database. Let's just, again, print the graph schema. Perfect. So I'm going to use 3 questions to show you when a simple agent will fall short and why we need to improve that agent. So one of my questions is, what was the cast of the casino? So for this question, the agent simply needs to find casino in movie notes and connect it to actors node and find out all the actors that played in that movie. The second question, what are the most common genre from movies released in 1995? So it needs to go through movies, filter the ones that were released in 1995, and then go and find genres of those specific movies. Question 3, what are the similar movies to the ones that Tom Hanks acted in? So the agent needs to find Tom Hanks in actors, connects and finds all the movies that he acted in, and then connects those movies to similar movies and find out what are the similar movies to those ones. So these are the 3 questions that I want to use. Let's go through the agents. So just like the previous video, you can just simply load one of the LangChain classes, in this case graph cipher Q&A chain. It requires graph, and mainly it is because it is extracting the graph schema from that graph. It requires LLM, and I'm going to just put verbose true in order to see all the steps that it is going through. Next, you can simply pass the query in a dictionary and invoke the chain. So in case you do it, you will see that the chain comes back to you with LLM response. So the first question was about what was the cast of the casino, and these are the cast and the actors who were in casino. Let's also pass the other 2 questions. The second question was, what are the most common genres for movies released in 1995? The answer is, I don't know the answer. Let's go through the third question. What are the similar movies to the ones that Tom Hanks acted in? The answer is, I don't know the answer. So this is why I'm calling this agent a simple agent. Literally, you have to run 2 lines of code and pass the values of the graph and the LLM to it, and you have access to the agent. But the agent clearly is not powerful enough to give us the answers for question 2 and question 3. So from here, my main goal is to improve the agent in order to be able to also answer the other 2 questions. And just to give you some more context, in case I use the other GPT 3.5, that model will be able to give me the answer for question 1. Also, it will be able to give me the answer for of the question 2, but it won't be able to answer question 3. So as you can see, just by switching the model, we will be able to get the answers for 2 questions, and we will only need to improve the agent for the third one. So that is, again, a very important thing to keep in mind. Use a powerful large language model in the backend so you can have the full power and the best performance. So just to make it more simple for you, in my source utils, I have this module called importchain.py. I will open this module right here. So we can actually, I will put it here because I modularize this improved agent there, and it is easier to understand the big picture from it. So in order to create the agent, these are the steps that I need to go through. So let's also scroll down a little bit. Improved agent contains 4 main steps. Detecting entities in the user input. Match entities to the database. So it extracts the entities and it also searches to find out where those entities are located in the database. Then we create a custom cipher prompt that takes the entity mapping information along with the schema and the user question to construct a cipher statement. So as you can see, we are going to help the model to understand where the model can access those entities in the graph database. And finally, it is going to generate the answer and give the answer to us. So these are the steps that we are going to go through. Prepare entity chain, prepare a cipher prompt using the entities that we created, prepare cipher response, prepare response prompt, and finally, I'm going to prepare a chain from all the previous steps that now not only sees the user's question, but also has access to a cipher query that is able to extract those entities from the database. So this is very important. These steps are going to allow us to have a much more powerful agent than the one that we just saw. So let me close this one and again go back to our notebook. So the first step is to detect the entities. I'm not going to go through the step-by-step of what is happening inside the codes, and I will just skim through them and go through them quickly because it is just going to make the video very long, but feel free to go through them. I added a lot of comments, a lot of description of what is happening. You can also go through LangChain's documentation. Feel free to just dig in and dive deeper if you want to understand exactly what is happening. So for that, we need a class called entities, and we are going to pass these two prompts, which essentially tells the agent what to extract. It is going to tell that LLM to extract person, movies, and years from the text. You can add or remove more entities in order to match it to your own dataset. So for now, for the movies dataset, actually even not the years one, this is something that I use for personal exploration, but for now we only need person and movies. So let's extract these two. So as soon as I extract these two, like I prepared the prompt, I can put them in this chain of create a structured output chain, pass the class that we created, pass the LLM, and pass the prompt that we created. And as soon as I pass those questions to this chain, you are going to see that it is going to extract the entities within those questions. In the next step, I can tell my agent what to do with all those entities that it could extract from the question. So we extracted person and movies. I'm telling the agent that extract the person and movies nodes and store them into a variable called p, and try to find out where p.name contain the value or p.title contain the value. So since we extracted the person names or movies, those names can be found in one of these two directions. And in case you could find them, just tell us where did you find them. So this is a function that wraps everything together. Let's create that function and let's run it. So we had two questions. Question number 2 and 3 were the questions that our agent failed to give us the answer for. As you can see, right now, it could give us the location of Tom Hanks in our notes. It says Tom Hanks maps to Tom Hanks person in the database. But for the second part, since there was a year involved, it didn't return anything because I didn't include the year in this query. So I used the year personally, and I tried to explain to the agent how to also extract the years from my database, but that just would make things a little bit more complicated. So I removed it for this step, but I strongly recommend you to start, as I did, start playing around with these values, with this database, and start to, teach the agent more information and more information until it is dominantly able to extract the information that you are looking for. Another important note is that our search is now relying on the correct spelling of our entities. However, just to make it more reliable, apply fuzzy search and make sure that even if there is a misspelling in your entities, your Cypher query is still able to retrieve the locations of those nodes and the properties that those entities represent. So in the next step, I just want to use the knowledge and the information that we found earlier, which, as you can see, Tom Hanks maps to Tom Hanks person in the database, and create a Cypher template and inform our agent where to look for those specific entities. So again, I'm not going to go through these steps, but now the Cypher query that is being generated from those information looks like this. As you can see, now passing that question, the Cypher query that was generated includes the question, includes the entity, and also includes the place that that entity exists, which is a person. So this is going to allow our agent to easily find that name and start extracting information for it. And finally, all we need to do is to wrap everything up, pass the Cypher query that we just generated to our agent so it is able to do everything for us. So let's wrap everything up. Now this is our agent. Let's start asking the questions. Question 1, 2, and 3. Interesting. So one thing is the agent was able to actually give us the answer for all the 3 questions. Although we saw that the process somehow failed to extract the information for the second question. That is an interesting observation that I had. So in general, introducing those extra information to the agent was somehow allowing our agent to even return the value, like the answer for the second question as well. That is why I actually removed that year from my Cypher query here, because I wanted to show you that even without introducing the exact piece of information to the agent, it is somehow able to understand and to retrieve the answer for that second question. So up to this point, we have an agent that is able to give us all the answers that we are looking for. And this is just another question. How many of the movies have the action genre in them? And there are 5 movies, and we will see in a moment that when I'm going through the chatbot that actually all these answers are correct. Perfect. I want to give you an exercise. So I want to give you this question. From the movies that were taken in the United States, how many had the comedy genre? This is a question that we are failing to get the answer for. I'm not going to explain why it is failing. Fix this question, open a pull request on the repository with an extra notebook that is able to solve this question. I would check your answers and I would merge the pull request for you in case you are interested to work on it. But this is something that I wanted to just leave here, because keep it in mind that even with the current configuration, with the improved agent, there are scenarios and cases that we still cannot get the answer for. However, even this question, you can solve it. But the main concept that I wanted to explain here is it takes more time than a RAG pipeline to implement a proper graph agent and start interacting with your graph database. And this is exactly why I told you in the beginning that having the knowledge of what knowledge graph you want to construct is going to help you a lot. Because if you know what you're looking for in your database, then just like these questions, you can start improving the agent, you can start improving the whole system until you can extract the information that you are looking for. Perfect. So this is the 4th notebook, and let's jump into the final notebook. All right. In this notebook, I want to show you how to perform vector search on that last vector index that we created from our tagline column, and we stored the embeddings in the graph database. So let's first load the libraries, load OpenAI credentials, again creating the embedding function, and also load an instance of my Azure model. Then let's also connect to our graph database. First of all, the user will ask a question, we convert that question and we get the embeddings. Next, we perform the vector search using the embeddings that we just created from that question. And for that, you can use this function, db.index.vector.queryNodes, to perform the vector search. This function receives 2 variables, like values for the variables question embedding and top k. And as you can see, I'm retrieving the top 3 values, and the question embeddings are these embeddings here. So let's print the top 3 values. What was the question? What movies are about crime? Heat, Tom and Huck, and Balto, I believe, if I'm pronouncing it correctly. And the reason that they were retrieved is because of these descriptions: a Los Angeles crime saga, the original Bad Boys, and part dog, part wolf, all hero. And you can also see the scores for the vector search for each one of those results. In the next step, I pass this result along with the user's question, along with the system role to my large language model. So you can see that this is how I'm preparing the prompt, question, the results, and the system role. And I just ask my large language model to give me the answer. There are several movies about crime. Some of them include these three. If you pay attention, the large language model is not able to use its own judgment on the retrieved result right now. This retrieved result with these three sentences are just not enough for the large language model to understand which one is actually about crime. Maybe this one is not about crime, but how does it know? This one is clearly about crime, and this one sounds like is about crime, but you got the point. Our model is going to only rely on the information of one single column to come to the conclusion and give me the result. So in case you want to perform the vector search on the information of one column, make sure that your information it contains enough information for the large language model so it can understand what is happening. So in case if I ask what movies are about love, let's just change this question. Again, you can see that even if I ask the movies about love, the first movie is the Los Angeles crime saga. The second movie actually has something about love in it. And so again, you can see that the model tells me Heat, Grumpier Old Man, and Tom and Hawk are the movies about love. So that's it. And in this cell, I just wrap everything together to perform the whole process in one execution. And this is exactly how I'm going to do it in the backend. So we just went through all the notebooks and we saw all the steps that are needed to design our chatbot. So now let's see the chatbot itself, and then I will quickly show you the Microsoft project for Medical Chatbot. So in order to run the chat, okay, so first, the chatbot again is in source. You can see the app.py. It has the user interface. I kept it very simple. It has three functionalities: the improved agent that we just saw, the simple agent, and the RAG side of our project. The default value is on the improved agent, and it's going to communicate with our backend through these two functions, which are technically the same. Both of them are pointing to this function. And as you can see, the function checks for the user's choice. So if it is the simple agent, it just uses the simple agent. If it is the improved one, it uses the improved agent. And if it is the user is asking for RAG with the graph database, it performs all the steps that we just saw in that cell and run the RAG pipeline on it. So let's run the chatbot and ask a few questions. So if I want to run the chatbot, that is how I can run it. And let me go to my Explore folder and open Explore Movie Data. Here I have a couple of questions along with their answers from our data frame. And I just want to ask those questions and verify the performance of our chatbot. So the first question is, what movies did Powers Booth act in? So let's open up our chatbot. Okay, let's ask that question from our improved agent. So this is giving us Sudden Death and Nixon. The answer is Sudden Death and Nixon. Let's just quickly perform the same search with our simple agent. Our simple agent was also able to give us the answer, but clearly if you switch to RAG, it is not going to give you the answer because it is going to perform the vector search on the values of the tagline column, and that single column has no information to give the large language model enough knowledge to give us the answer. But as you can see, our large language model is just hallucinating because it lacks the information that it needed to come to the right conclusion. So I will skip this question, and this question. Let's ask this question. So what are the most common genres for movies released in 1995? So I will just go to the first. Let's check the simple agent. I'm sorry, I don't have the information to that question. Let's test the improved agent. Perfect. The most common genres for the movies are comedy with 10, adventure with 6, action and romance with 5, and children with 4. Let's check. Comedy 10, adventure and romance, adventure 6, romance and action 5, and children 4. So let's ask another question that we saw in the notebook, but also let's ask it here. So what are the similar movies to the ones that Tom Hanks acted in? So right now, even our improved agent is not able to give me the answer. So perfect. You can see that actually sometimes, oh, now it did. So as you can see, the performance is not as stable as you would like it to be. And again, the main reason is because of the large language model itself. So if you improve it, at least using a better GPT 3.5 or GPT 4 would definitely fix these small mistakes at least. So the similar movie is Finding Nemo, and the reason behind that is Tom Hanks, the only movie that it appears for Tom Hanks is Toy Story, and for Toy Story we have Finding Nemo as a similar movie. And finally, let's ask this question: from the movies that took place in the United States, how many had the action genre? So this is the question that I showed you in the notebook. That feel free to work on it and let me know if you could solve it and fix it. So let's test this one, and I expect to see an error. Perfect. You can see that the chatbot is not able to actually get the answer for that question, and that is why I left that question for you as an exercise. So we just saw the performance of our chatbot. We just saw all the necessary steps that we need to take in order to design this chatbot on our CSV database. You saw that depending on what information I want to extract from my CSV database, I need to modify the agent and I need to give it enough power to do it for me. So now I want to show you the Microsoft project that I mentioned earlier in the video, and I want to just go through some of the key steps in that project and explain how they designed the medical chatbot. All right, so in that chatbot, I mentioned that they have designed this knowledge graph from unstructured text data. So this is the prompt that they pass to the large language model, and we are going to see the code actually in a minute, and ask that large language model, which is GPT-4, to construct this prompt, to construct this knowledge graph for them. There are a few keynotes here. First, pay attention to how they created their entities, nodes, and their relationships. So this is a perfect example of how you can ask, for example, GPT-4 to construct a knowledge graph. But as you can see, they already knew exactly what they are looking for. So these are the nodes that the authors wanted the large language model to create for them with these piece of information, along with these type of relationships, which, as you can see on the right, you can also see all those relationships in that knowledge graph. So there are two keynotes that I want to mention here. First, if you run the project with any model except GPT-4, like any of the older models, like GPT 3.5, any of them, that project is not going to run for you. And at some point, you are going to run into an error. And the main reason behind that is GPT 3.5 is not able to handle the amount of the context length that they are passing to it, along with the instructions that it is being received from the prompt. The other thing is, as soon as you start to run the project and you try it multiple times, actually you will see that GPT-4 is going to come up with various structures of the knowledge graph, which might be the same, let's say at least 90% the same as what we asked it to create for us. But at some point, it is going to generate different nodes and different relationships as well. So that was a very interesting observation that I had when I was working with that project, because there is that element of inconsistency in the performance of GPT-4, and you have to keep it in mind. Not GPT-4, any large language model, especially when you are dealing with such complicated prompt and those type of unstructured data. This is a very complex task, and at least for now, I believe GPT-4 is among the best models that you can use out there. However, in the future, by the new models getting longer context length and also becoming more powerful, I assume these type of problems are getting easier to solve, but still at this point, these are the two big challenges that we are facing. So now let me show you the code and just quickly go through it. So in the README file, they provided you with all the information that you need to execute the project. The project is using a Streamlit for the user interface, but the part that I personally am interested in, so in the UI, as soon as you have the graph database, you can start interacting with it and start chatting with it. As you can see, they are emphasizing on the use of GPT-4 32K at least. So this is the model that they used. And let's go into ingestion file and let's go into ingestion.ipynb. So this is the notebook that I'm going to go through because this is where they construct the knowledge graph and store the information inside the graph database. So from the top, they just import all the necessary libraries that they have in mind. This is an example of that text, another example from those data. So first they clean the data, they load the OpenAI credentials, they create a function that gets the text, like this example here, gets the system role and all the information that the LLM requires, and generates the output for us. So this is the function, and this is the graph that they are trying to construct. And this is the code that I just showed you. And then they go through the text, and they actually right now they just pass one example, the one that I showed you earlier, to the function just to test it. Here is the test. They test the model here, and then from the result of the GPT model, they extract the entities, the nodes, and they extract the relationships in order to be able to store them in the graph database. This is what they are doing here. And then is the time for the data ingestion. They connect to the graph database. They create all the necessary nodes that they had in mind. These are the nodes that they had in mind. You can see that it says for each unique case, for each unique person, etc. And then they write a for loop on all the data to run the GPT model on them and to store the information inside the graph database. So keep it in mind, running this code, as they have mentioned here, is going to take a couple of hours. But this is a fantastic project that you can build using the power of the knowledge graph and a powerful large language model. What this project allows you to do is then to extract information that might be very beneficial, for example, for medical purposes. Doctors can now start exploring the database, going through different information, and understand very valuable information from those unstructured data. So that was the second project. Thank you very much for watching the video, and I hope to see you in the next one.